Hello everyone, my name is Amorita with student ID 2024-32051. In this video, I will demonstrate as well as explain the program process for my practicum report regarding time series analysis using the ARIMA model. So here, I will try to predict Bitcoin price for the next 7 days based on historical data. Okay, so we start with cell 1, which is the import library stage, and here I prepare several main libraries needed. First, there is pandas for doing data frame manipulation, then the request library to fetch data from the internet, and matplotlib for graph visualization needs later. In addition, for time series modeling, I import the ARIMA module from stats models as well as mean squared error from sklearn to evaluate the accuracy level of the model, and we are going to create it. Moving to cell 2, which is the data acquisition or data fetching step. In this process, I fetch Bitcoin price movement data directly from the CoinGecko public API, and through the URL, I specify the request parameters for historical data over the past 45 days in USD currency with a daily interval. And using the request library, the raw data is then pulled and convert to JSON format so it can be processed into the next stage. Next, in cell 3, the data pre-processing process is performed. Now, from the JSON data obtained previously, I extract the price data section or prices because the initial time format from the API is still millisecond time stamps. I create a new data frame named df raw with timestamp and harga USD columns, and this timestamp column is then converted into a standard date format, which is year, month, and date to make it easier to understand. Next, in cell 4, we arrange the final structure of the data frame, and since time series analysis requires a time-based index, I set the clean date column as the main index of the data frame, and after that I take the top 45 rows of data and ensure the data frequency is set on a daily basis using the asfrec the function. Okay. Next, in cell 5, I do data splitting or splitting data, and this is 45-day historical data is divided into two parts, namely training data and testing data. And for the training data, I take all rows of data except for the last 7 days. Meanwhile, the last 7 days of data are allocated specially as testing data, and which will later be used as a reference to test the accuracy of the model's prediction. Okay, in cell 6, the ARIMA model fitting process begins, and here I declare the ARIMA object using the training data prepared previously by configuring the parameter order 1, 1, 1, and this parameter represents the value of P, D, and Q, which means this model uses an autoregressive component of order 1 and differencing of level 1 to make the data stationary and a moving average for order 1. And after all parameters are set, the model is then trained using the fit function. Okay, next. After the model is finished training, we enter cell 7 to perform forecasting using the forecast function. The train ARIMA model is requested to predict Bitcoin price for the next 7 days, and where the forecasting date range is adjusted exactly to the date range in our testing data. Okay, next, in cell 8, I evaluate the model's performance using the mean square error or MSE metric, and the mean square error function here is used to measure how large the average deviation is between the ARIMA model prediction results against the original actual data. The MSE value that appears in the output is a representation of the error rate of the prediction. Okay. Before saving the analysis result data, cell 9 and cell 7, I prepare for data factoring in both cells and the index of each data frame. But the original actual data and the ARIMA prediction result data is reset back to a regular column, and in addition, I add a new column named status with the content data asli or original data on the actual data and Hassel forecast ARIMA forecast result on the prediction data as disgusting as a distinguishing marker. Next is the saving step is carried out in cell 80. And here, the original data and the prediction result data are merged vertically into one unity using the PD concat function. And after being merged, all the data is exported into an Excel format file with the name data, time series, and prediction XLX. And the success of this process is marked by the appearance of the text output file Excel berhasil dibuat. And finally, in cell 12, we enter the visualization part using a line graph or a line plot. And as we can see together on the graph on the screen, the blue line with circle markers describe the original actual price movement of Bitcoin. Meanwhile, the red dashed line with X markers is the prediction result from our ARIMA model. And overall, this program has successfully automated all stages of time series analysis, starting from data fetching via API, cleaning, predictive modeling with ARIMA, to data export and informative graph visualization. And that is the explanation regarding the program process of my practicum report. Thank you very much for your attention. See you in the next video.